Welcome back to Quantitative Reasoning. In the previous tutorial, we learned how to find out about the format of a data frame. For example, how many rows and columns are there? What are the column names? In this video, we learn how we can access individual elements in a data frame and build subsets consisting of selected rows or columns. Do you remember how we accessed elements of a vector? We used square brackets. For example, scores in square brackets 3 returns the third element of the vector scores. For data frames, it's similar. The only difference is that for vectors, it was enough to put a single number inside the square brackets. But data frames have rows and columns, so we must identify elements with two numbers. Let's look at an example. If you don't have our Titanic project open right now, please reopen it and click on titanic.r to open the script in the editor pane. Next, we run the read.csv command to bring the Titanic data frame back into our environment. Let's open the data frame as a spreadsheet by clicking on the variable name in the Environment tab. Suppose we're interested in the element in the second row and fourth column. We access this element with Titanic in square brackets 2, 4. The first number in the square brackets stands for the row, the second number for the column. In the console, we see that the element is 21. Indeed, this value matches the number in the spreadsheet. We can get a sequence of consecutive rows with a colon operator. For example, to get the second to the fifth row of the fourth column, we type Titanic in square brackets 2, 5, 4. In the console, the numbers aren't shown as a column, but as a vector, that is, from left to right instead of from top to bottom. Apart from this difference, the numbers are the same. We can also use the colon operator after the comma, for example to obtain the third and fourth columns. If we want all columns, we could type 1, 11 inside the square brackets. But there's a shortcut. If we want all columns, we just leave the second argument blank. What can we do if we don't want every row between rows 2 and 5? For example, if we want only the second and fourth. Here, the C function from tutorial 2 makes a comeback. Instead of 2, 5, we write C and in parentheses only those row numbers that we want to keep. Okay, now over to you. What do you think happens when we run the following? Titanic in square brackets, comma, C 1, 3. There are many lines of output. Let me scroll up to see the beginning. We left the first argument in the square brackets blank, so we take all rows. But we included only the first and third column. Because there are too many rows to display, R doesn't print all of them in the console, but although hidden, the remaining rows are still part of the output. This fact is what R is telling us by saying that it omitted 1708 rows. Instead of addressing the first and third column by their index numbers, 1 and 3, it's also possible to address them by their names, that is, fam name and gender. If we want to extract a single column in a data frame, say the column age, we would not need the C inside the parentheses. If all we want is a single column, there's an even shorter alternative, the dollar operator. Titanic $age. When we extract a single column, the result isn't a data frame, but a vector. Consequently, we can apply the same subsetting operations that we learned in tutorial 2. For example, Titanic $age square brackets 2 returns the second element of Titanic $age. Here we don't need a comma inside the square brackets because Titanic $age is a simple vector, not a data frame. If we want the second to the fifth element of Titanic $age, we can use the colon operator. Do you remember which of our earlier commands returned the same numbers? It was Titanic in square brackets 2, 5, 4. You may be wondering why we even need the dollar operator if we can accomplish the same without it. The answer is that more complex subsetting operations are often easier with a dollar notation. Suppose we want only those rows from the data frame that correspond to 40-year-old travelers. We could, of course, scroll through the spreadsheet and note down the row numbers. For example, there's a 40-year-old traveler in row 20, and again in rows 90 and 107. But searching through the spreadsheet is tedious. The purpose of software such as R is to automate such tasks. Here is how to do it with the dollar notation. Titanic, in square brackets, Titanic $age equals 40, comma. Don't worry if you don't immediately understand why this command did the trick. It'll become clearer in tutorial 8. For right now, let's view the syntax as a recipe that we can adjust when we face similar problems during our next in-class activity. Just bear in mind that, in order to test for equality, we must type 2 equal signs. A common mistake is to forget the comma before the closing square bracket. But the comma is important, because we get an error without it. Following this pattern, do you see how we can create a subset of the Titanic data frame that only contains second-class passengers? Let's remind ourselves that this information is in the column called class. The character string to indicate a second-class passenger is 2ND. We follow the same recipe as before, but we change age to class and 40 to 2ND. Note that we must surround character objects such as 2ND by quotes, as we learned in tutorial 2. Even restricted to second-class passengers, there are still many rows of output. So let's save the output in a variable called sec_class. Variable names mustn't start with a number, and they mustn't contain spaces, but we can, for example, use an underscore. Let's open sec_class as a spreadsheet. Because sec_class is a data frame, we can apply all functions we learned in the previous tutorial. For example, we can find out with nrow how many passengers were in the second class. While we are typing, RStudio tries to autocomplete the variable name. Autocompletion can be very convenient because it reduces the probability of making a typo. If RStudio proposes the correct name, and here it does, then all we need to do is hit either Tab or Return. So there were 271 second-class passengers according to our data. We'll keep working with the variable sec_class in the next tutorial, but for now, let's return once more briefly to the original Titanic data frame. A common question we have about a column in a data frame is how many different values it contains and what these values are. For example, how many different classes of passengers and crew are in the class column. We can find it out with the function unique. With unique Titanic $class, we can see that there are 4 classes: third, crew, second, first. The result is in the order of first appearance in the column. Here is a summary of the main points of this tutorial. We learned how we can create subsets of a data frame with square brackets. We separate the row indices from the column indices with a comma. If we want all rows or all columns, we can leave the corresponding entry in the square brackets blank, but we mustn't forget the comma. If we want a single column of a data frame, we can alternatively use the dollar notation. After the dollar, we type the name of the column we want to keep. We can use either column numbers or column names when working with square brackets, but we can only use column names when working with the dollar notation. We can obtain the unique values in a vector with the function unique. Besides extracting individual values or subsets from a data frame, there are many situations where we'd like to add a new column to a data frame. Next time, we learn how to accomplish that task. See you soon.